So what are the learning objectives? After this video, you will learn the various codes and its importance. Codes just like BCD code, gray code, what is parity generator, what is parity checker, how we can convert from one code and another code, what is error detection, means what is error, how we can detect it, what is the Hamming code, how we can utilize the Hamming code for the detection of error, and so on. So the topics to be covered are positional number systems, binary coded decimal codes, parity generator, parity checker, Hamming code, and conversion from one code to another code. Apart from this, we will see what is access3 code, how we do the addition of BCD codes, how we do the addition of access3 code, what is the positional number system means 8421 code we will teach. So all these things we will learn through this video. So as in the previous videos, we have seen that in digital electronics, the number system is used for representing the information, and number system has various bases. Okay, suppose if a number system represent digit from 0 to 9, it is a decimal number system. But our computer does not understand our real-time language, so we have to encode the data. So encoded data means representation of letters, alphabets, numbers or words by specific symbols or values that our computer understands. So any digital system involves the digital data being stored, represented and processed in the form of binary bits, because our machine, our computer understands the language of zeros and ones. So when we are talking about alphabet ABC, or we are talking about the decimal number system or any other octal number system, but we have to convert it finally to that language, that system that the computer understands. So it is converted in the binary bits. Otherwise, we can say that digital coding is a characterization of letters, words, symbols, and digital format. We are characterize these values in a binary digits so that the output is understandable by the computer. So we will start with the positional number systems. Okay, first of all we will understand what is positional number system, and then we will use this positional number system further. Okay, so as the name suggests, positional, so it means each digit has some weight and it is as per the position in the number. For example, if I say 1101, so each and every bit has some position associated with it, corresponds to its positions. Just like in the case that we were doing in the conversion from one number system to another number system, for example octal, then we did a to power 0 into that number plus a to power 1 into that bit. So this 0, 1, these are the positions. Okay, so these are the examples of positional number systems: octal, decimal, binary, hexadecimal or BCD, etc. Okay, this is the positional number system. So in which systems the each bit has some weights according to the positions, then it is known as the positional or weighted number systems. So in digital number system, for the fast processing of the information, data is used in binary format. Some are weighted codes and some are non-weighted codes. For example, if a number is 1000001, it represents 65 in the state binary. But when I say that okay, convert it into BCD, then it is having a number 41. And if I say that okay, convert in ASCII code, it is A alphabet. So each and every code has its different style, different format to be understood. In positional number system, we simply want to say if it is a number, for example, A, B, C, D. So D has some position, C has some other position 0, 1, 2, 3, and this is the final value can be found out by the position. As I have told you earlier also that the positional number system is that number system in which each position is associated with some kind of weight. But in non-positional weighted code, there is no relation in between the positions and the weights. Examples of the positional codes are binary, octal, decimal or hexadecimal. Apart from these number systems, other examples are 8421 code or BCD codes. Whereas non-positional codes in which no relation in between the weight and positions are gray and access3 code. Now the binary, octal, decimal, hexadecimal, 8421, BCD are known as positional. Let's take an example that why and how the positional number system name is associated with these kind of number systems. These kind I mean to say binary, octal, decimal or hexadecimal. Let's take a number 1011. Otherwise also it is, for example, 101. I'm taking a complete number here. So here when I have to convert this binary number into a decimal number, okay, we will see the positions of these bits. Starting from 0 here, it is 0, 1, 2, 3, and after decimal it will be -1. These are the positions. Now you will see that these positions are having a role in conversion. Because it is a binary number, so 2 to power 0 into 1 plus 2 to power 1 into 1 plus 2 to power 2 into 0 plus 2 to power 3 into 1. This is the into 1, and similarly you can take the values as 2 to power -1 into 1 plus 2 to power -2 into 0 plus 2 to power -3 into 1. What I am doing, I am just multiplying the values. See, value is 1 having the position 0. So 2 to power 0 means it is having the rule r to power 0. R means radix. So in case you are converting binary to decimal, you will take 2 to power 0 into 1. In case it is just like octal number system, then you will take 8 to power 0. If it is decimal, then you will take 10 to power 0. If it is hexadecimal, then you will take 16 to power 0. So 2 to power 0 into 1 plus 2 to power 1 into 1 plus 2 to power 2 into 0, 2 to power 3 into 1, 2 to power -1 into 1 plus 2 to power -2 into 0 plus 2 to power -3 into 1. Okay, after that you can solve it. For example, 2 to power 0 into 1 is 1 plus it is 2 because it is 0, 0 means nothing. So plus 0 plus 8, okay, plus 1 by 2 plus 1 by 8. Okay, so further you can solve it while converting into this binary to decimal, that it is 8 plus 2 plus 1 is 11, and then in the other side also you can convert 1 by 2 is 0.5 and 1 by 8 is 0.125. So it will be 11 point, it is 0.5 plus 0.125, it will be 0.625. So final answer will be 11.625 with a radix 10. So here we have seen that while converting binary into decimal, the role of the positions play an important role. Okay, same like just 8421 method, each and every bit has some positions associated. 8421. For example, I have to show 15. So it will take 1, 1, 1. This one has weight 1, this one has weight 2, this one has weight 4, and this one has weight 8. So the final value will be 15. 8 plus 4 plus 2 plus 1 is 15. So in this video, we have seen that how number system is bifurcated into positional and non-positional and why it is known as positional number system. And I have shown that how each and every weight is associated with the positions. So in the next video, we will see what is the coding BCD numbers are there, what is gray code, what is XS3 code, what are the parity bits. So that's all about the today's video. Thank you so much. We will meet in the next video soon.